In this video, we're going to do an example where we find the value of a derivative and we're going to use the formal derivative definition. This example, instead of x and y, we have s being a function of t. So we are asked to find, reading this, ds dt, the derivative of s with respect to t at t equals -1. If we are given this function s, or s of t, equals 1 minus 3t squared. So our formal definition, s prime of t, or exactly the same, ds dt, that is going to equal the limit as h approaches 0 of s of t plus h minus s of t all divided by h. All right, so ds dt equals the limit as h approaches 0 of s of t plus h. So that means I have 1 minus 3 t plus h quantity squared minus my original function, 1 minus 3t squared. Notice how I'm using parentheses, all over h. All right, so we need to simplify the numerator. This should be pretty easy for us to simplify. It's just foiling and combining like terms, remembering to distribute negatives. The goal, once we have done that, we should be able to factor an h. There should be a common h that we can factor out and we'll cancel with this h. Remember, we need this h to go away so we can plug the 0 in. All right, so continuing to work on my derivative, I have the limit, and again, we write that every time as h approaches 0, of 1 minus 3. T plus h quantity squared, t plus h squared, is t squared plus 2th plus h squared. And of course, I have to distribute a 3 to that, or a minus 3 to that. And then I've got minus 1 plus 3t squared, all of which is over h. So this is the limit as h approaches 0. I already see that 1 minus 1 is going to go away. And in the numerator, I have negative 3t squared minus 6th minus 3h squared. And then I have my plus 3t. And that should be a squared up there. It's a squared down here. All of which is over h. And if we do this right, notice I left that 2 off right there when I was originally writing it. I just wrote it in. But if we're doing this right, all of this should almost always cancel, especially if it's a polynomial, it will definitely cancel. Okay, so that cancels. Now I'm left with the limit as h approaches 0 of negative 6th minus 3h squared over h. Notice both of my terms in the numerator have an h in them. So this is the limit as h approaches 0 of h, negative 6t minus 3h, all over h. So those h's cancel. To find my derivative, I'm calculating the limit as h approaches 0 of negative 6t minus 3h. And that gives me, when I take that 0 value and plug it in for h, I've got negative 6t minus 3 times 0, or negative 6t. So my derivative here, the derivative of s with respect to t is negative 6 6t. Just trying to use that little dot, negative 6t. This represents my derivative. Now, what were we asked to do with that derivative? If I go back up to the top, you'll notice we have here where t is equal to negative 1. So this means we're going to take that derivative and evaluate it at t equals negative 1. So, ds dt, where t is negative 1, is negative 6 times negative 1, or positive 6. So that would be my answer. That is my rate of change at t equals negative 1. So I have a derivative and I have the specific, my instantaneous rate of change at that point. So just thinking about what we did, we took a polynomial, a quadratic polynomial, and we used the definition of the derivative in order to find the derivative and then evaluate that derivative at a specific given input. And that's it for this video.